Hi everyone. Hopefully your preparation is going well. These are the questions we are going to try in today's episode. If you have tried these questions, then go ahead and watch the solutions and discussion related to it, which will be starting right away. And if you have not tried it, we'll recommend you to try it once before you watch the solutions. Before we start today's discussion, let me take a moment to introduce some fascinating courses at Mathoratory. Simply visit our website and check the plethora of options that we provide for CAT, GMAT, and other aptitude test preparation. We strongly believe in providing flexibility and convenience to students as per their requirements. Very recently, we have launched our live workshops for CAT and OMETs, which will be conducted every Sunday from 25th of April 2021. Every area of testing will be dealt in these live sessions. It will also include strategy sessions and special workshops on top MBA entrance tests for Indian B schools. In each of the workshops, we will provide live tests as well as live analysis of those tests for the specific topic which is being discussed in that workshop. Instead of purchasing the entire bundle, initially we are offering the option to register yourself for a single workshop. Just visit the workshops page under our courses and scroll down to get the option to register for the very next workshop that is going to be conducted. Let's now continue with today's video and have an enjoyable preparation ahead. The first thing for this question is to obviously factorize the a square minus b square. So you get this form a plus b into a minus b is equal to 1001. And when you're factorizing the variable side, also try to factorize the numerical value. So this is 7 into 11 into 13. I mean, even if you don't know, you should be observing that this is a multiple of 11. You just divide and then factorize. So you have this first step. I mean, this has to be done. Now, the question is looking for how many integral solutions we have of a comma b. Now, whenever you have the same question in terms of positive integral solution, there is some more constraints, and because of that, the number of solutions will automatically limit itself. But even when you have integral solutions, you should start with positive integral solutions. So first, what I'll do is I'll try to find the positive integral solutions, and from there in I'll figure out the integral solutions. It's actually safer to do it in this way. So when we're looking for positive integral solution, a couple of things you should be taking note of. One thing is a plus b and a minus b will be simultaneously odd or even. I mean, if you do not note this for this particular number, even then you would not make a mistake because 1001 is an odd number. But the other thing that you should be taking care of, and this is for positive integral solution by the way, a plus b is bound to be greater than a minus b, right? Because b is positive. So what we know is this a plus b is bigger factor of this number 7 into 11 into 13 compared to a minus b. And factors always exist in pairs, right? So if you know how to figure out the number of factors, this is nothing more to do. All you have to do is figure out the number of factors of this number and then half it, because all the higher set of factors can be associated with a plus b. For example, you can pick up 1001 for a plus b and then correspondingly 1 for a minus b. You can pick up 7 into 13, for example, 91 and then 11 for this. You can pick up 11 into 13, 143, and 7 for this. Similarly, 77 for this and 13 for this. So each of these are going to give you some values of a and b, which are positive integers. So I'll just show one example. So if I have a plus b as 1001 and a minus b as 1, so from this you will get a as 501 and b as 500. So that will satisfy the condition, right? But remember, the question is looking for how many integral solutions we have. So for each pair of solution that we have considered in this case, so these four pairs, so let me take this example again, 501 comma 500. Correspondingly, we are going to have a total of four different solutions when a and b are integers. Just the negative ones are also allowed. So it's something like this. I mean, a and b could be both positive, both negative, positive negative, or negative positive. So you'll have four possible solutions for each solution out here. So effectively for four of these solutions, you have 4 into 4, that is 16 possible solutions of this particular question. So the answer to this question should be option C. We're looking for how many integers in this range 1 to 100 are divisible by none of this 2, 5, and 7. So we are going to use a very basic idea. We are going to apply set theory out here. So first, let me just draw three circles out here. And let me indicate these circles as multiples of 2, multiples of 5, and multiples of 7. So I'll start with the very basic thing, and that is the centermost region. So the centermost region out here is indicating multiples of 2, 5, as well as 7, right? So multiples of 2, 5, and 7 implies multiples of 70. From 1 to 100, there is just one multiple of 70, right? 70 itself. So this is pretty easy to do. Now let us focus on this region, multiples of 2 and 5. So multiples of 2 and 5 implies multiples of 10. So from 1 to 100, there are 10 multiples of 10, right? Just simply 100 by 10 will give you the answer. So you have 10 multiples of 10, but one of this is this number, this 70, which we have already counted. So there will be 9 numbers out here. Similarly, let's continue here. So multiples of 2 and 7 implies multiples of 14. Again, in order to figure this out, just simply divide 100 by 14 and just collect the quotient. So there are 7 numbers. Now, out of those 7 numbers, one of them is this. So there'll be 6 numbers out here. Multiples of 5 and 7 are basically multiples of 35. Now, this you can simply use basic logic. I mean, there are just a couple of these, right? 35 and 70. 105 is crossing over 100. 70 you have already counted here, so just one more number out here. Now, all you have to do is fill these gaps. So multiples of 2 out here are total of 50, out of which this is 9, this is 1, this is 6, so that's a total of 16. So take off from 50, so you have 34 numbers left out for here. Here you have 9, 1, and 1, so that's 11 numbers, but multiples of 5 total are 20. So take off 11 from 20, you have 9 left out here. Multiples of 7 are 14, again 100 by 7. That gives us a quotient of 14. 6, 1, and 1 adds up to 8, so this should be another 6. So now all you have to do is just count how many numbers are inside this region, because we are supposed to count whichever is outside the region, right? Not multiples of 2, 5, and 7. So there are 100 numbers in total. By the way, this entire circle is 50, right? So you don't have to add this up. These are the multiples of 2. Apart from that, you have this 9, 1, and 6. So 50 and another 16. So that's 66 numbers inside the region. So outside the region, you should have 34 numbers, and that should be the answer to this problem. This is a nice idea on remainders. You must have experienced a question like this when you're preparing for any aptitude test. But having an option out here, and that too such nice options, you should solve this question within 5 seconds. See, whenever you are reading this part, if I distribute them equally among 10, 16, or 20 children, I would be left with one toffee. So when you divide among 10 children, you should be left with one toffee, right? So the number of toffees should be of the form 10k plus 1. So the first thing you should understand is it's an odd number straight away, and also the last digit is 1. Both of these need not be checked because there is only one odd number out here, and that is 161. That will straight away give you the answer. Let's say that you don't have options. I mean, there are a lot of aptitude tests nowadays which doesn't give you options. Treat it in that way also. So let me just solve this for you as well. So when you divide this number by 10, the remainder is 1. So I'm just writing the remainders here. By 16 as well, 1. By 20, the remainder is 1. And the last statement, if I distribute the toffees equally among 23 children, I would not have any toffees left with me. So basically divisible by 23, right? So when divided by 23, the remainder should be 0. Combine all of this in one go because the basic idea of remainders, this number when divided by 10 leaves a remainder of 1. So let's say the number is n or something. Then n minus 1 should be divisible by 10. N minus 1 should be divisible by 16. N minus 1 should be divisible by 20. So n minus 1 should be divisible by the LCM of 10, 16, and 20, which is 80. So you should have the number of the form 80k, n minus 1 that is. So n should be of the form 80k plus 1. So all you have to do is justify which number of this form is multiple of 23. So just keep on putting values of k, 1, 2, and 3. Or you can reduce this a little further. So you have 80k plus 1 should be divisible by 23. Notice that out of the 80k, the 69k will be anyhow a multiple of 23, right? Irrespective of k. So you have something like 11k plus 1 remaining. In order for this 80k plus 1 to be divisible by 23, this is anyhow divisible. So this part should be divisible by 23, right? So just notice that if you put k equal to 2, this becomes 23. So k equal to 2 satisfies. So you can just substitute it here and you get the answer. So that is 161. So option D is the answer. Again, in this question, so we have to find the largest 5-digit number which when divided by 8 leaves a remainder of 3. So it has to be an odd number. Odd and even are easy to check, right? Again, we have options. So these two are anyhow eliminated, even numbers. And this is not even a 5-digit number. So this is also eliminated. So option C has to be the answer. But again, if you have to solve this out, so first target is to figure out the general form of this number. So you have the number of the form 8k plus 3 definitely. But when divided by 7, this should leave a remainder of 1, right? So this is what we have been given, this same number. So I'm writing n as 8k plus 3, whatever is the number. This, when divided by 7, should also leave a remainder of 1. Again, check this out. 8k divided by 7. So 7k will always be divisible. So just eliminate the 7k. So you have k plus 3 by 7 should leave a remainder of 1. In other words, k plus 2 when divided by 7 should leave a remainder of 0, or k plus 2 should be divisible by 7, right? So k plus 2 will be divisible by 7 for k is equal to 5. That, I think I don't have to explain that. So if I put k equal to 5 here, then what I'll get is the minimum possible value of n that satisfies. So the minimum possible value of n that satisfies is 8 into 5, 40 plus 3. So that is 43. So 43 is the least possible number which satisfies this. Anything of the form 43 plus LCM of the two divisors that we have, 8 into 7, 8 and 7, sorry, into whatever quotient q or something. So this will be the general form of the number. So the number will be of this form. So this is 56. So 56 k, q or k, whatever. So let me write q again, 56q plus 43. Now you can verify which of the options is satisfying this condition. Hopefully you like the solutions we provided for these questions. And if you did like it, do not forget to like the video and share, subscribe, and comment. And if you plan to prepare with us in a structured manner, then do check the courses in our website. We strongly believe in providing flexibility and convenience to students as per the requirements. You will have an option to either take a full course or learn exactly what you need to. For instance, if you plan to prepare one-to-one live with mentor, you can book sessions for only doubt clearing or even just for analyzing your mocks. Even for CAT preparation, if you don't need the one-to-one guidance, the mocks, the mock analysis, the workshops, or the GDPI, which are actually included in the comprehensive course, and you just want to train for specific topics of your choice, then simply select a capsule from these numerous options which are available to you. It will cover everything from basics to all variations and applications of the topic under study. Take a trial or book a demo with us and select the course which best suits your needs. Thank you for joining in and have a pleasant preparation ahead.